Good morning, everyone. So, we are today speaking about, we'll see about what is rhodamine. So, looks safe, but is it? HPTLC detects rhodamine B adulteration in food and cosmetic. Hello, everyone. This is Parth Trivedi from Anchrom Enterprises as a designation senior application specialist. And by the look of the title, you can see looks safe, but is it? Because your small negligence make a major consequences. As these images are coming over here, as you can see these images. Yeah. So what is the common thing you are seeing in these images? This all the bright colors and all. Yes. So look at this, some foods over here. Looks so tempting over here. Yes. And the beautiful cosmetics looks attractive now, but they are hidden with toxic danger. But with the help of HPTLC, we'll find out the presence of rhodamine in food and cosmetics, like your in image. So, uh, what is rhodamine B and why it is banned? So, rhodamine B, it is a, what do you say? It is a synthetic dye, which is actually a very easily dissolved in water, and it belongs to the xanthine family. And you can see with the help of structure over here also that the xanthine structure over here with the three ring structure. It's basically a xanthine family is notified. And the use of it is used in textile, plastic industries, and somewhere in a research laboratories also. Whereas it is very toxic, you must be uh, aware of it. That's why we are presenting over this. And this is banned in India. Okay, so this is banned by FSSAI, which is food based. It is also banned in cosmetic and drug industries, which is also have a health hazard. Like it is mutant the DNA. It even affect your liver, kidney also, and at certain stages when you use excessive in amount, it causes cancer also. So, despite the ban, it continues to be illegal use for its strong coloring power or and low cost. Today we will look at how we can detect this dangerous compound using HPTLC. So, uh, why it is dangerous? Okay, so it is illegally found in food, cosmetic. As you can see in food, such kind of like jalebi, ice gola, and any other bright colors of foods, you can observe with this kind of thing. And majorly it's used in cosmetic because it's have a very nice bright coloring effect. And as I mentioned previously, it is low cost and it is easily available in street products like some of the small vendors. It has a health hazard, as I previously mentioned, but what kind of health hazard it has? Like if you consume a little more or daily basis, it may you face a skin or eye irritation, or even you can see a eye swelliness, and at a certain stage you get a nausea. For the longer term effect, as you take a more and more you are consuming for the daily purpose, so it may cause your liver or kidney damage also, and even it can cause to your cancer risk may can be seen. That's why the detection of rhodamine B with the help of HPTLC is crucial. So, what is HPTLC? As I'm saying continuously about HPTLC, is HPTLC. HPTLC is a high performance thin layer chromatography. It is a modern and advanced version of TLC. It otherwise anywhere you can see the TLC and HPTLC, actually these both depends on adsorption chromatography only. But whereas in HPTLC, it is completely automatic, and it is accurate. You can do repeatable analysis. It complies with global standards, like as in mentioned over here, like GLP, USP, EP, and it has a compound separate based where you can separate by using a stationary phase with the help of your mobile phase. And at a certain stage you require derivatize, you can even derivatize and check the fingerprinting analysis on your plate. And the main important thing on the second last point, you can see it is only chromatographic method that generate image based result. As you know, we mainly believe when we see anything. Okay, so this image-based result varies also. It ideally used in herbal, food, pharma, cosmetic, and also as well as in forensic. Yes, you are right. Also in forensic. So why HPTLC for this kind of testing? Okay. So HPTLC is one of the most efficient tool for detecting banned substance like rhodamine B in food and cosmetic. It allows, okay, yeah, it allows for the detection of non-permitted dye with high precision. And when we say simultaneous analysis of multiple samples, we really mean it. We can analyze both food and cosmetic on a single plate, and not just one or two, but many at once. We will actually see an example of that in one of the upcoming slides. Method also affects accurate fingerprinting and spectre matching, which helps us confirm the presence of rhodamine B coefficiently. So in the further slide, we will observe like this kind of thing. And all of this, one more thing, and while being cost effective, this instrument, it's simple, and also using minimal solvents also, make HPDLC an ideal instrument for fast and reliable screening in routine lab analysis. So let's see. So these are the HPLC system with the some of the data outputs you can see over here. So first for the application, we yes, for the application purpose, you can see over here applicator. So applicator, what is the role of the applicator? While we are taking a HPTLC plate, you know the normal TLC plate. When we take a TLC plate, this instrument take makes a bands automatically, just giving a command using the VisionCat software. Whereas this all instrument connects with the VisionCats, and we can use with the help of software with a single software. Yes. So this applicator do the washing of syringe with its own self. It doesn't require the syringe cleaning. Then after the application, we go with the development with the help of ADC. So automatic development chamber, it also helps to uh, check the do not that our plate does not come under that humidity, so it controls the humidity also, and it's automatically stop the plate running as we notice that we have to run till 7 centimeter or 8 centimeter. So it will automatically stops and remove the plate, control the humidity, dry the plate, and ready for your further uses. And after that, we go for the visualizer. Where is the visualizer? We can go with the three type of lights. Win with the white light, then we go with the 254 nanometer lights, and then 366 nanometer fluorescence. As you can see, the above image shows about 366 nanometer in a fluorescence light. And after the conducting with the visual images, as you can go with the standard, or you can go for the quantification or qualification, both quantification and quality. After that, you go with the scanner. Scanning is that's why I was saying about the, if you want to for the, if you go with the quantification, that how much amount of with respect to standard your band is like rhodamine is present. So you can go with that also, but anyways rhodamine is band in it, band overall. So then if you see a single amount of rhodamine in it, so then it's already banned, you can't use that already. And if there is some of the limitation remain in some of the compounds, so you use this kind of thing. And after, we required a derivatizer, because some of the compound require derivatization, like some of the flavonoids does not come after just development, or we can't go with the visualizer and to confirm it that there is a at this RF the compound, the flavonoid is present. So we go with the derivatization using a specific derivatizing reagent, and after that we can visually see the band and we can go for the visualization. And above all this, the you can use the VisionCat software for controlling all the this system of HPTLC. For the sample preparation, this is a basic sample preparation for the preparation of food and cosmetic product, as we conducted using the weighing balance over here. We have taken as an example for this image purpose as a sample candy floss. We have taken the candy floss, and with the using diluent 4:1 methanol water, we have diluted in it. and then done the sonigation for approximate 25 to 30 minutes. After doing the sonigation, we have transferred the in append of tube and done the centrifugation for the 2000 rpm for 5 to 10 minutes. After doing the centrifugation, we collect the supernatant and then we transfer to the supernatant to the R vial for the further application purpose. For the standard and sample preparation, this is a perfect method what we have used. For the rhodamine standard, we have used 1 milligram of rhodamine B standard and dissolved in 1 ml of methanol is to water, which was our diluent, which is 4:1 solution. And then we took 1 ml of stock solution and then dissolve it in 9 ml of same methanol is to water, which ratio was 4:1. That solution make concentration of your 0.1 mg per ml. This is a much better best of concentration for the analysis of your rhodamine B to check in your sample also. For the sample preparation, we took, because in sample the market or any company may add very little amount of rhodamine. So we have taken 4 gram of sample in 5 ml of same methanol is to water diluent 4:1. Done the same process of sonication, centrifuge, collected the supernatant and it was collected for 0.5 ml and collected and make it with the 1.5 ml of methanol is to water 4:1. Whereas we have done this sample preparation for all the food and cosmetic, all kind of samples. For the chromatographic condition, you can see we have taken the stationary phase for the 20 by 10 centimeter plate, which is TLC aluminum silica gel 60F254 with this Merck catalog. Mobile phase, we have taken tetrahydrofuran, toluene, formic acid, and water, which the ratio contains of 16 by 88 by 2 by 1, which is volume by volume. The developing distance we have chosen for the 70 mm, which is 7 centimeter from the lower edge. So for the plate, the normally we get the plate of 20 by 20 while purchasing, and yes. Okay. So while purchasing the Merck plate, you get the 20 by 20, but we have to require to cut it for 20 by 10 analysis. So yeah, we can play video that how to cut the plate. So this is a TLC silica gel 60F254. We remove the plate. You can see it's a completely clean, and we have to put it upside down because we don't require to disturb the silica of that. We have pre-cutted glass of 20 by 10 so that we get a proper measurement, and with the help of using cutter or blade you can do it, cut with properly in a 1 to 2 goes, and you can see the plate has been cutted in the 20 by 10 size. Yes, so this is the 20 by 10 plate, TLC plate. We will use the scale for the, as we will go run with the 7 centimeters, so we will mark for the 7 centimeter to check out for that at what stage we will use it. And after that we will name the project number or project name, whatever we have to require. We will clean the properly with the help of soft brush, so we don't disturb the silica. But if any like dust particles coming over the silica, so we can clean it. And after, because we are cleaning, because just because after taking the visualizer, taking a photo image on the with the help of visualizer, so that we can't take on it. Then we go for the, after cleaning the blade, we go with the application purpose using a automatic TLC sampler 4, which is ATS4. Okay, so this is the hood. You have to open the hood and place the 20 by 10 plate with the proper alignment as given there. Close it, and this is the vial area. This is contained total 66 vials from first to end. This we have placed the rhodamine from first to end over there, and we place that over here. Close the container and give the command with the help of vision cat, and you can see this syringe is taking approximate 4 times cleaning of the syringe, because rhodamine is a very bright color, so you have to clean the syringe properly also. And one by one it is taking the sample and applying on a plate, and after the applying, it also doing the cleaning in each and every band after that. Yes, so this how it applies the band, and you can see some of the band over here. These are the very bright bands, so they are very completely visible. But over here, these have very less concentration, so that's why this may can't see the rhodamine B band or your sample band. We don't know if rhodamine B present in or not. We will see in our further slides. So the preparation of the mobile phase, we prepare a mobile phase in a proper stopper conical flask, and we have a proper arranged pipette for each and every solvent. So we don't mix up with other using pipette. So tetrahydrofuran, toluene, formic acid, and water with the ratio 16 ml of tetrahydrofuran. Take the toluene 8 ml, and then we take a formic acid 2 ml and water 1 ml. We will mix it properly, thoroughly, and they're ready for the use for our run. Let's see that how to use that, because the mobile phase is more than 20 ml, and for the TTC chamber with the 20 by 10, we required only 20 ml of mobile phase. So how to do it? Let's see. This is a TTC chamber, the side view of it, and we take the 20 ml in a measuring cylinder. For the first, when we pour this mobile phase TTC chamber, we require saturation. So we will see the how to we get the saturation per work. Yes. So this is a saturation pad. We put a saturation pad at a front face and put the 20 ml of mobile face linearly, and keep the lid above it and till the 45-degree, so that it divides in 10 by 10 in front and rear. So we are doing for this work, we have done the remove the saturation pad to check out that how the run will be happen, that the how the bands will be going to be separated, because on the front end you can see a saturation pad, so you will not be able to see that how the separation is going on. So we have removed the saturation is required because uh, for the we have done the 20 minutes, of saturation for, so that it can completely make a nicely gaseous chamber in that, so your bands get completely properly visible in it. So you can see we have poured 20 ml in it, cover the lid, tilt it for 45-degree, it separate by 10 by 10 ml in front end, and saturate for 20 minutes using saturation pad. And after that we will place our plate, and after placing the plate you can see that run is going on. It already made a proper under a nice gaseous phase, so that you can see a visibly bands separating and going upside, and you can see the mark over here. We have made a 7 centimeter mark here, so that we will run till that, and we'll remove the this RTLC plate. And yes, so the run has been completed, and after removing the TLC plate we will dry it and do the further analysis, as you can see. Yeah. So this is a CAMAG TLC visualizer. So it looks like this, and we will see first of all that how the visualizer looks like from the inside. So yeah, this is a visualizer. This is inside this. Just take the point A, B, and C. This. So I will explain it for the A, B, and this C point. And yes, this is a shape slit. When we place A point to A point over here, so you can place 10 by 10 plate. And when we keep here from B to B, you can see you can place for 20 by 10 plate. And we keep C to C point, you can place for 20 by 20 plate. So while you give the command, so it's look like this. When you give the command for the white light, it takes from the 254 and 366. So let's see how to place the plate first of all. So this is a run plate. We have placed in 20 by 10, and we close the sheet and give the command with the help of visualizer. This is in white light. Then you will see a image in 254 and then 366. This happens automatically with the help of visualizer. We don't require to do manually. If you want to just to check, and we can go with it, but just with the help of visualizer you can check it and you get the image like in the further slide you will see. And after the image we go with the scanner. So this is a CAMAG TLC scanner. For for this, you have to open this door and press the load button so that your plates to the placing plate area will come outside like this. You have to place your plate, the complete run plate. The place your plate from properly with the help of this scale 10 centimeter. You can see, and put the magnet over here so that while scanning, your plate does not move. And yes, so after placing the load, it will go inside and close the chamber, close the door. And after that, you can give the command. While scanner actually used for the quantification purpose, but we are using for the spectrum purpose in this, so that we can check that the band we are seeing, its band is actually a rhodamine band or something else dye. So that's why we have done this. So yes, you can see the white image of rhodamine B. So this is the standard over here. You can see at the RF of 0.5. This is the rhodamine over here. And we have taken the some of the sample from the market. As you can see, tutti frutti, which we can see in the breads also. So where we can't see any band over here. The whatever the compound or dye is it does not suitable for this mobile phase. Whereas we have taken the proper mobile phase for the rhodamine B only. Then you can see the sugar coated jelly candy. You can see a very light band over here. So that means it contains the rhodamine in a very small amount. After that, you can see in jelly that we have an all small pack of jelly. It does not contain any rhodamine. After that, the very famous cotton candy, person comes in roadside and rings the bell, and it sells that cotton candy in pink color. So it shows the rhodamine in a lesser amount. But yes, there's a presence of rhodamine where it is already banned, where it's not present in halwa barfi. And after going with the cosmetic, completing with the food in sindoor, that's normally females use it. So the other bands are different dye, but at the same RF, you can see at 0.5 there is a presence of rhodamine. And after that, in lipstick, this was a maybe these lipsticks may be going with the uh, that cosmetic department. They check it. That's why there is no presence of rhodamine. Where you can see the same color of pink color over here, this spectrum does not match with this rhodamine B. So that means this is something else dye which they have used for the coloring purpose. And whereas you can see in liquid lipstick, there is a rhodamine. It's very nice, brightly color. We can see over here. Also in blusher, eyeshadow, and nail polish. You can see other bands also, but these are some different dye. But these all the coming on the 5 RF. These are contained with the rhodamine. While you can see this all the what I'm saying about. Whereas we can't only confirm with the white light. So we have this rhodamine B is fluorescence active. So we have taken in a fluorescence. So now you can easily see in a sugar coated candy over here. It's very light in cotton candy also, and sindoor also, but not in lipstick as I told you. See over here in this area. So this all contains rhodamine B. We have taken some of the few samples only from the market area and some small vendors, so that because we know the most of the branded are going with the quality controls and got also checked by the government authorities, where some of the local vendors where the manufacturer is going in a small area and they don't have a particular name or they are just selling it. So from that kind of area we have taken this and check this all this thing. So yeah, this is the result. So we have detected in this sugar coated jelly, cotton candy, sindoor, liquid lipstick, blusher, eyeshadow, nail polish. Yes, and this is the spectrum analysis of rhodamine B to check out. In this spectrum, there is we have compared with the rhodamine B. There is one band of rhodamine B and other band of this all detected rhodamine in all the food and cosmetic. So you can see the spectrum is completely matching. So that means it is a rhodamine only. And some of these compound food and cosmetic we didn't find in tutti frutti, jelly, halwa barfi, and lipstick. There was no presence of it. Yes, and like how to identify and avoid product with rhodamine B. So, as you know that, first of all, remember that whenever you see that neon pink and bright red color, these are the mainly red flags for you. So you have to always be aware of it. And of course, in the lab, we rely on HPTLC, a fast and reliable method to detect such banned substance, as you've seen in previous slide also. So how to avoid it? So mainly avoid the street foods or using street foods. So always check, and you can go for the analysis also. And mostly buy, as we already know, we are the that we have to always purchase the food item with the FSSAI mark. And for the cosmetic, we check about the ISO approved cosmetics. Or if you find such kind of any suspicious, you can also contact to the local authority officers also. And yes, so for the use lab method, you can go with HPDLC. You have seen that how it is very nice. You can check the bands and all. So yes, you can see the like the keynote over there downside. I've mentioned that safety starts with awareness. Choose certified, trust your senses. So that's why detection is very crucial for it. But who will be very helpful for it? So the benefit from this method will get the if the FSSAI or FDA people use this kind of instrument system, so they will be very helpful for it for them. And with the cosmetic regulation authority, can use in quality control, quality assurance laboratories, and in manufacturers and food cosmetic products, even in public health laboratory, because it is very important for the safety of the publics. And even you can use they can use for the academic and research institute, and contract testing laboratories, where if someone want to test, they don't have a lab, they go with the another outsiders, and check the presence of rhodamine B. And yes, yes, you can contact us for the instrument and about the system. And to for the further inquiry, like you can go with our Anchrom website also, or you can mail us at lab@anchrom.in, or simply contact us on this number. And yes, you can also check our for the this video, like this webinar also will be published on this Anchrom YouTube website also. And or we have many more videos present in this YouTube, that how to use the instrument and all about it. You can get updated with the help of this you can follow us on LinkedIn, so that you get always be updated. And also you can connect with the Facebook also. And thank you so much